All right, welcome to chapter 5. So chapter 5 is going to be about polynomial functions. We looked at a couple types of polynomial functions, linear functions, quadratic functions. They're going to be more higher order, so like x cubed, x to the fourth, stuff like that. But before we talk about that, we do have to talk about exponents. So the first thing we're going to look at exponents, we're going to look at the properties of exponents. So recall that simplified expressions do not have negative exponents, they do not have parentheses, and all the fractions are in the simplest form. All right, so something like this well, it's not a polynomial anyways, but a simplified expression, this would definitely not be simplified. This would not be simplified. It violates all three of those. It has a negative exponent, it has parentheses, and it has a fraction that's not simplified. Of course, to simplify this, we would distribute, we would turn the exponent positive, we would simplify this fraction. All right, a couple of things. We're going to look at that in a minute. Recall, polynomials have exponents that are whole numbers, polynomials, all right? Just because it's an expression doesn't mean it's a polynomial. Polynomials in particular have exponents that are whole numbers. So x to the third, polynomial. X to the 1/2, not a polynomial. The degree of the polynomial is the degree of the monomial with the highest exponent. So for that, you're just looking for, each term, you're looking for the term with the highest exponent, the highest degree. We'll look at that in a little bit. So let's look at the properties of exponents. There's a couple of properties, or a few actually. Negative exponents. Negative exponents, simply, if you have a negative exponent in the numerator, to make it positive, you bring it to the denominator. And if you have a negative exponent in the what am I looking at here? Oh yeah, if you have a negative exponent in the denominator, it comes to the numerator. All right, so for instance, x to the negative second power, written as a positive exponent, would be 1 over x squared. And vice versa, 1 over x to the negative second power would be written as x squared. It just switches numerator and denominator. Zero exponent, anything to the 0 power is 1. So 2 to the 0 power, 1. 3 to the 0 power, 1. Anything to the 0 power is 1. Product of powers, when you multiply the same base, different exponents, you add the exponents. An example of this would be 2 to the third power times 2 to the fourth power is 2 to the seventh power. Power of a power, if you raise an exponent to an exponent, you multiply them. So for instance, 2 to the third power to the second power is 2 to the sixth power. 3 times 2 is 6. Power of a product, if you have a product raised to a power, then the power can go to each factor of the product. So for example, xy to the second power can be written as x squared y squared. It would go to each term or each factor of the product. Quotient of powers, so when we multiplied bases that were the same, we added the exponent. 3 plus 4 is 7. When we divide or have a quotient, we subtract the exponents. So for example, x to the fifth over x to the third is x to the second. 5 minus is, or in other words, in other words, it would be x to the 5 minus 3, like it's the m minus n, 5 minus 3, which is x to the second. And then power of a quotient, if you have a quotient, the power can go to each numerator and denominator. So 2 over 3 squared can be 2 squared over 3 squared. All right, let's see how we can use this to simplify some expressions. So for instance, negative exponent, 5 to the negative 2 power. To make it a positive, we would put it in the denominator, 5 to the second power. Or we could rewrite this as 1 over 25. Now, if you look at number 2, you will see that the negative exponent is on the 6 and it's on the y. So these are the only two that should change. The 6 to the negative second should go to the denominator, and the y to the negative second should go to the numerator. So the y to the negative second, to make it positive, it comes to the numerator. The x is still in the numerator. The x has not changed places, so the x is still in the numerator. And then in the denominator, we have 6 squared. All right, we do want to write this in the right form. So the x and the x should come first. So x, y squared, and then 6 squared is just 36. So this would be the simplified form. 0 power. So anything to the 0 power is 1. So xy to the 0 power is 1. And negative 7 to the 0 power is 1. That's the 0 power. This was the negative exponent. Product of powers. So when you have the same base, and they're multiplied, then you add the exponents, a plus b. So in this case, it would be x, a plus b, because they're multiplied, negative 1 plus 5, which is x to the 4th. All right, now 2 and 3 are not the same base, so they can just multiply together. 2 times 3 is 6. However, the x's, x to the 4th and x to the negative 10, those do have the same base, so we can add the exponents, 4 plus negative 10. And that becomes 6x to the negative 6th. Uh-oh, this is not simplified because the exponent is negative on the x. So the x, to change that to a positive exponent, needs to go to the denominator. So the 6 is still a numerator. It's its own term. It's still in the numerator. The x to the 6th is now in the denominator with a positive exponent. All right, so power of a product property, x to the a, y to the b, to the c power. The c just gets to go to both, multiplies to both of the exponents to give ac and bc. So in this case, we have to view each thing as having its own exponent. So this is negative 4 to the first power. It has an exponent of 1. And x to the negative 5th power. So this 2 is going to go to both of those exponents. So it's going to be negative 4 to the 2 times 1, so squared, x to the 2 times negative 5, so x to the negative 10. And now we have an issue. It's not simplified because this x has a negative exponent. So the negative 4 squared, well, that's 16. Negative 4 times negative 4 is 16. And then in the denominator, x to the 10, because now that it's in the denominator, it's now positive. So we have 16 over x to the 10th power. Number 2, so you can view this as 3 to the first power, x squared, w to the negative 3rd power. So this 1, negative 1, will get multiplied by each power. So it's 3 to the 1 times negative 1, so 3 to the negative 1, x to the 2 times negative 1, so x to the negative 2, and the w, negative 3 times negative 1, is positive 3. All right, well, some of this needs to be fixed because we have negative exponent, so the 3 is going to have to go to the denominator, and the x to the second, to make it positive, the w to the third is still in the numerator. So we have w cubed over 3x squared. We no longer need the 1. It becomes a positive 1 here, but we no longer need it. So we can leave it invisible. So that's product of powers and power of a product property. Quotient of powers property says that x to the a over x to the b, we simply subtract them, a minus b. So m to the fourth over m to the sixth, so we would subtract the 4 and the 6. It'd be m to the 4 minus 6, which is m to the negative second. But we don't want negative exponents, so it is going to have to go to the denominator. So 1 over m squared, because if there's nothing left in the numerator, then it's a 1. So 1 over m squared. All right, so, well, this we can just divide. That becomes 1 over 5, because 5 over 25 is just 1 over 5. So we got 1 over 5, and then 3 minus 8, so x to the 3 minus 8, and then the y, 2 minus 2. When you're using the quotient of power property, 3 minus 8, 2 minus 2, they always stay in the numerator, all right? You're subtracting them in the numerator. So this becomes 1/5, or we could just put it over 5. So this becomes x to the negative 5, y to the 0 over 5. All right, well, some of this stuff's going to have to change, because this y to the 0, that's just 1. So we don't need that. That's just 1. X to the negative 5, that's going to have to go to the denominator. So we have 1 in the numerator, since there's nothing left up there, and then 5x to the 5th in the denominator. Now, you probably could have figured that out just by looking at the problem. If there's 3 x's on top and 8 x's on bottom, then 3 of these x's would cancel with 3 of these, and you'd be left with 5 x's. And the y squareds just cancel each other out. This simplifies to 1 over 5, so we have 1 over 5x to the 5th. And that's the same thing with number 1. If you look back at number 1, 4 m's on top and 6 m's on bottom, 4 of these m's cancel with 4 of these, and you're only left with 2 m's. So it's 1 over m squared. All right, power of a quotient is kind of like distributing the power to the numerator and denominator, AC, BC. So this negative 3 is going to go to the 5th to the 5 on the numerator. It's going to go, because remember, this is 4 to the first power. So we got x to the negative 15 over 4 to the negative 3, because 1 times negative 3. All right, well, some of this is going to have to switch places, because this is negative, so the 4 comes to the top with the power of 3, and the x goes to the bottom with the power of 15. They're both going to switch because they're both negative. And 4 to the third power, 4 times 4 is 16, times 4 is 46. Yeah. Wait, is it? Wait, no, 64. Four times 4 times 4 is, yeah, 64. So this is 64 over x to the 15th. All right, number 2. All right, this 2 needs to go to each factor. So this is 2 to the first, x cubed, over 4 to the first, y to the 4th. So this 2's going to go to all 4 of these. So it's 2 squared x to the 6th, 2 times 3 is 6, over 4 squared y to the 8th. Alright, so this is 4x to the 6th over 16y to the 8th. And 4 over 16 reduces to 1 over 4. So this is x to the 6th over 4y to the 8th. Alright, when you add, subtract, and multiply polynomials, you always get a polynomial. So that means that polynomials are closed under addition, subtraction, and multiplication. That's called closure. When you add a polynomial to another polynomial, you get a polynomial. When you subtract a polynomial from another polynomial, you get a polynomial. And the product of two polynomials, you multiply a polynomial by another polynomial, you get a polynomial. So polynomials are closed under those three operations. However, when you divide polynomials, you sometimes get a polynomial. That means polynomials are not closed under division. You can see these two examples. X to the 5th is a polynomial, x to the 3rd is a polynomial, x to the 5th divided by x to the 3rd is x squared, that's also a polynomial. But for the next example, if you flip them, x cubed divided by x to the 5th is x to the negative 2nd, which is not a polynomial. 1 over x squared is not a polynomial because the squared is in the denominator. It's not a polynomial. Alright, so the homework for this section, there's a worksheet on Canvas. Make sure you show all the work or there's no credit going to be given. Alright, thank you.